from central limit 0. What do we have? We have x1 plus x2 plus all the way up to xn. N in this case is 25, right? This is what we call sample total. Sample total should follow. Sample total should follow approximately normal. Okay, approximately normal. With mean of the sample total and variance of the sample total. As I have just shown you, expected value of sample total is a mean. Variance of sample total is n sigma squared. Okay? But what is mean? Remember EX1 is mean. This is the box. 1, 1, 2, 4. Okay? I make n draw from the box with replacement. So EX1, a single draw, is mu. Mu is, in this case, average of the box is what? Is 2. Okay? How about variance of x1? It's sigma squared. I just show you this is 1.5. Am I correct? So look at here. What's n mean? N is 25, mu is 2. So this is 50. This one here, n is 25, sigma squared is 1.5. So this number is 37.5. And 37.5, I'm going to rewrite as 6.12 squared. Okay? Now, let's come back to see the probability we want to find. We want to find sample total between 75 and 50. Or equivalently, I want to find sample mean is between 3 and 2. Okay? Between 3 and 2. So how can I find sample total between 50 and 75? How can I do that? Look at it. This is sample total. Follow approximately normal. Okay? Follow approximately normal. Center at 50. So this is 50. And we want to find how likely sample total between 50 and 75. This is 75. So in other words, we want to find the size of this shady area. Okay? And how big is the size of the shady area? First step, we need to standardize what? Sample total. Standardization is any random variable subtract by its mean divided by its standard deviation. Gonna convert to z-score. Okay? In our case here, expected value of sample total is how much? Is 50. Do you see that? So replace by 50. And square root of variance sample total, 6.12 squared. You take square root is what? 6.12. Okay, this is the way how you standardize it. So 50 minus 50, give me 0 here. And 75 minus 50 divided by 6.12. This number is 4.08. So we look for the shady area. The size of the shady area is probability that z-score between 0 and 4.08. Okay? Between 0 and 4.08. Now, recall, the largest z-score in our table, 3.49, and everything towards what? The left. This shady area is 0.9998. So how big is the upper tail? It's only 0.0002. In this case here, okay, in this case here, how big is this area? Let me write it down for you. The upper tail. This is 4.08. 4.08 is even bigger than 3.49. So what can you say about this area? It's even more close to what? 0%. Can you see that? So probability from here to here, you can treat from here to infinity. Because this area is almost 0. Okay? So in this case, it's half of a standard normal curve. Half of a standard normal curve is what? Is 50%. So this answer is about 50%. Now, a very difficult question, you can solve in a very what? Nice way. Is that okay? Done.